Thank you very much. I'm very, very happy to be back at Øvet. I should say that this is joint work with Richard Baldwin and Tony Venables. And as a curiosity, in fact, all three of us were part in the very first Øvet in 1988. So it's great to be back. This is also the first theory paper of the day. I'm going to talk about links between jobs and technology, and in particular to focus on general equilibrium effects. There is, of course, let me just get this right. There is, of course, a lot of literature and policy attention related to technology and jobs. Most of this is empirical, but there are also theoretical contributions. In the theoretical frameworks, they are most often either partial equilibrium or multi-sector models without very much focus on the general equilibrium effects. They focus very often on the trade-offs between job-destroying substitution effect and job-creating demand effects of technological progress, and they don't really try to capture factor market interactions between sectors. So what we intend to do in this paper is really to focus on these general equilibrium mechanisms. We look at the interaction between the nature of technical shocks and the nature of the sector or sectors in which they occur, and show that these interactions do have quite significant impact on the labor market outcomes. And we also show that the results may be significantly different from what a partial equilibrium framework would give. There's quite often in the literature either a one or a two elasticity relationship linking technology and labor market conditions, wages, or employment. Let me just give two very brief examples. If we look at one sector models with two factors, for example, then there's only one elasticity which is important, which is the elasticity of substitution between the two factors. So basically the sign of the relative wage effect, if there's factor augmenting progress for factor A, say, would depend on whether the two factors are gross substitutes or gross complements. So it's either a factor saving effect if sigma is less than 1, in which case the relative wage of the augmented factor goes down, or a factor using effect if the sigma is greater than 1, in which case the relative wage goes up. So that's the elasticity of substitution. If we look at, say, two or more sectors and two factors, then another elasticity comes into the picture. Then basically sectors interact in the goods markets and in the labor market. So if you look at an example where one of the factors are robots and the other one labor, for example, then if robots become more efficient or cheaper, as some references, some literature study, then there'll be a job destroying substitution effect, less use of labor because robots are more efficient, but there'll be a job creating demand effect if the cost reduction implies more demand. So the sign of the wage effect and the sign of the employment effect in the sector in question would typically depend on whether the elasticity of substitution is larger or smaller than the elasticity of demand. So these two kind of approaches, the 1 and 2 elasticity approaches, basically form the background for what we are looking at. Because we are going to start out with this, but focus on general equilibrium effects. Let me just briefly say something about related literature. As I said before, there's a lot of empirical literature which we don't refer to here at all, but on the theory side, the first three of these, Jones, Xu, and Haskell and Slaughter, use models very similar to what we are using, a Hexagon model, simple trade model, and look at technical progress. And all of these mainly focus on how relative wages are affected by technical progress for one of the factors. We differ from these in the sense that we look at employment effect as well as relative wage effects, and we also model technical progress slightly different from some of these. Acemoglu and Restrepo in a number of papers model technical progress in a different way in a task-based one sector framework where some tasks are automated and new labor using tasks emerge. Since that they normally work in a one sector framework, they don't really show any general equilibrium effects. And Gratz and Michaels and Otto and Dawn I've mentioned already typically look at least in some of these references on substitution between robots or computers and workers, and get typically a variant of a two-elasticity approach. We are going to model technical progress in a simple way as factor augmenting technical changes. But as I said, we focus on the general equilibrium effect, and that should probably apply also to these other approaches to technical progress. So our model is a very well-known 2x2 hexagonal lean model, 2 factors A and B, 2 sectors 1 and 2. As I said, technology enters as factor augmenting technical change, and all or both factors in both sectors could be affected. So these alphas in the production and cost function are the efficient parameters for factor F in sector S. So this is standard, and for relative demand, we use the simplest possible way of doing that. So representative consumer with homothetic preferences gives this relative demand function. We're going to look at changes. We use hat algebra, and these are just standard equations for equilibrium in a model like this. Just adding the factor augmenting technical changes to a standard hexagonal lean model. So the first one is price equal to unit cost in change form. The second one picks up the productivity function, and the third one is the factor market equilibrium functions for the two factors, and then demand equal to supply. These shares pop up sometimes. So omega is the cost share of factor A in sector S, and nu is the share of factor F used in sector 1. These will be important. The elasticity of substitution is defined in a standard way, just making sure that we use this in efficiency terms. So the alphas pop up here as well. And to simplify in the analysis, we're going to assume that the elasticity of substitution is the same in the two industries. So what we'll do is to use this framework to focus on how various combinations of these alphas, the factor augmenting technical change, affect relative prices and relative employment, and in particular relative wages and employment in the two sectors. To do that, we start with some definitions. We focus on relative effects. So on the goods side, the delta P hat is the price change for good 1 relative to good 2. The delta X hat is the relative production change for good 1 relative to good 2. But we are in particular going to focus on the factor market effect. So delta W hat in our setting is the relative wage change for factor A relative to factor B. So if delta W hat is positive, factor A gains relative to factor B, and so on. And delta LF is the relative employment effect in sector 1 relative to sector 2. So if delta LF is positive, say for factor A, then the employment of factor A goes up in sector 1 and down in sector 2. So these are some of the measures we are going to focus on. And we're going to look at the effects of various combinations of factor augmenting changes. And we use these summary measures to capture the combined effect of technical parameter changes. There is always a cost saving effect of factor augmentation and a factor saving effect. For the cost saving effect, for sector S, or sector 1 and 2. Chi1 is the weighted average direct impact of factor augmentation for the cost of good 1, say. And delta chi hat is the relative cost impact on good 1 relative to good 2. So that is the sector bias of any combinations, any changes of technology. On the factor saving side, the lambda F is the factor saving effect of factor augmentation. So it's a weighted average of the factor saving effects in the 2 sectors. And the delta lambda hat is the factor bias of any combination of technology parameter changes. So if delta lambda hat is positive, then it is as if the endowment of factor A goes up relative to the endowment of factor B. In the analysis, these 2 final parameters, delta chi hat and delta lambda hat, captures all the effects or most of the effects of technology changes in an efficient way. We use this setup to look at key labor market relations, and you'll see that these are quite familiar from standard Heckscher models, only adjusting for the fact that we add factor augmentation and technical change rather than to just look at the standard thing. So for relative wages, beta SS is the Stolper-Samuelson elasticity, which depends on the factor shares. So if sector 1 is factor A intensive, sector 1 is factor A intensive, then beta SS is positive, and so on. If you just think of this as without a tech shock, then the first equation here is simply the Stolper-Samuelson relationship between goods prices and factor prices. And what we add is this sector bias of any change in technology. The relationship or the relative employment and production effects are also familiar, but maybe not as easy to see directly. If we start actually from the bottom here, if we think of an endowment shift rather than a technology shift, then the change in relative production is a Rybczynski effect based on the relative change in endowments, if this were endowment changes, plus a price effect. In our setting, we don't have endowment changes, but we do have technology changes. And any set of technology changes have a kind of equivalent relative factor endowment representation, or delta V. So this delta V is the equivalent endowment change, or the endowment change that would be equivalent to the technology changes that we have. It depends on the direct effect of or the direct factor bias of the impact of technology change, and the substitution effects that takes place through factor prices and from the direct factor augmentation. Finally, let me say that the price effect comes in via what we call the relative supply elasticity, which is basically movement along the production possibility frontier. This is convenient to use as a shorthand for something, but we should note that eta is not a separate parameter. It depends on the substitution elasticity and on the Rybczynski and the Stolper-Samuelson things. Note that this parenthesis is always positive. Okay. If we use this, we get fairly straightforward, simple connections. The price effect depends on the factor representation, factor endowment representation, and the Rybczynski effect, mitigated by the elasticities. This gives relative wage and employment effects looking like this, and we should just observe that in these equations, all three elasticities pop up: the elasticity of demand, the elasticity of substitution, and these factor reallocation, sector reallocation elasticities, Stolper-Samuelson and Rybczynski. What we try to do is to see step by step how the various elasticities work by starting with a small open economy with given coefficients given on this slide. But I think I'll just move on and say that for the general case, these two equations, which are more or less what I showed you before, shows how the wage and the relative employment effects depends on the nature of the shock. And these are linked to the shock by these three variables that I mentioned: the factor bias effect of or impact of augmentation, the sector bias, and this factor endowment representation. Sigma enters various places, and both through the substitution here for the delta V and directly for the employment effects. We use these separators to look at special cases. So let me show you two cases in the 3 minutes I have left. If you look at a sector-specific case, so both factors experience better technology in sector 1, but not in sector 2. Then in our setting, the sector bias of the cost saving is straightforward. It is for sector 1. The factor bias depends on whether sector 1 is A or B intensive. So the Rybczynski effect comes in here. And that is also true for the relative factor endowment representation. The Rybczynski effect matters, so the factor intensities matters. So in this case, the labor market outcome, if there's a sector-specific technical progress in sector 1, depends on the elasticity of demand. If it's elastic, then the wage will go up if the wage for sector A will go up if this sector is A intensive and so on. The employment in the sector will go up in any case because that's given by the sector specificity. If we look at another case, factor-specific things, so factor A, say low-skilled labor or unskilled labor, becomes more productive in all sectors, but not the other factors. Then the sector bias of cost saving depends on the Stolper-Samuelson effect, whether this sector is, which sector is A intensive. Whereas the factor bias and the factor endowment representation is straightforward, given by the increased productivity for this factor. So in this case, the wage effect depends not on which sector it is, but it depends on the combined elasticities of epsilon and sigma. So the higher these elasticities are, the more likely it is that the wage will increase for factor A. The employment effects, on the other hand, depends on which sector is A intensive. So employment of both factors will go up in the A intensive sector and down in the other one. So even if both sectors experience the same type of factor augmentation for factor A, employment will go up in one sector and down in the other one. Summarizing this, this is the same cases. If we look at the sector augmenting case, then the employment effect only depends on the sector bias and the elasticity of demand. The wage effect depends on these two things, plus which sector is more labor intensive or A intensive. Whereas if we look at a factor augmenting case, then the wage effect is always given only by the sector factor bias and elasticities, whereas the employment effect depends on which sector is more A intensive. I will skip some other cases here, although they are, of course, very interesting. But in the interest of time, let me just skip these and say a few words about open economy issues here. So we look at this in general, but we realize that there are certain things that are important. So the elasticity of demand is very important. Openness and the size of the country is important in that sense. So the small open economy case was given in some of the slides. I didn't have time to talk about that. in the paper we look at a general case, and the smaller a country is, the smaller market share it has in the world economy, the larger would the elasticity of demand be. So the more likely it would be to have positive wage and employment effects. Technical progress is also important. If it takes place in only one country, and if this country has good export opportunities, then it's more likely to see positive employment and positive relative wage effects from factor augmentation. Of course, if technical progress takes place in all countries simultaneously, then it's like a closed economy with a lower elasticity of demand. And finally, we also add some indicative analysis of adding a non-traded sector. And interestingly, that works more or less as increasing the factor supply elasticity. So it dampens the relative price and wage effects and reinforces the relative production and employment effect of factor augmentation. So to conclude, within the minutes I probably don't have, what we try to show is that in addition to the standard mechanisms that the literature has been focusing on, it is important to focus on the links between the nature of the technical shock and the nature of the industries in which it appears. So these general equilibrium things matter. It means that we need to look at 3 elasticities, not only 1 or 2. And it also means, which I haven't had very much time to talk about, that there is not a one-to-one correspondence between relative wage effect and relative employment effects. Very much of the literature only focuses on relative wage effects, but we need to look at both to get a complete picture. Thank you.
Thank you very much, Jan. We have a question from James Harrigan, who is asking, what is new in your paper relative to SHU JIE 2001?
Good question. There is a lot of similar results in SHU 2001. We think that we go through this in a more, well, he goes through the whole set of cases as well. We try to clarify some of these effects. We try to use insights from trade theory a bit more systematically and get it closer to the well-known Stoppel-Samuelson Brzezinski effects and so on. But his point of departure is very similar to ours, I should say.
Any other questions? Any questions from our panelists? Okay, Swati, the floor is yours.
Great. So Jan, I really enjoyed how simple everything is and straightforward. It would be really nice if you had some kind of supply side elasticity, sort of like specific factor combined with hexaoline more. I'm thinking along the lines of the old paper that Jean has in the JPE, with some elasticity thrown in for sector to sector transformations, so that it's not all completely hexaoline.
We actually start out with a simplified model, which would be closer to a specific factors model, but only to illustrate the 1 and 2 elasticity approaches. So we don't really work that out in full, but there we have an elasticity that could vary between sectors and could work as you say there. Having said that, the hexaoline framework makes it looks very simple. It isn't necessarily very simple, but the fact that we were able to represent the relative supply elasticity in a very straightforward and simple way and so on simplified a lot of this. But there are many other cases that could be interesting to look at, definitely.